then your program suffers from underflow. So one logic of your code should be avoiding underflow problem. Okay. So another what should be done is when producer produces, okay, so it will produce and store it in that buffer. And because our buffer size is of 10, you have to restrict the producer from producing more than 10. For example, you can say that let us consider a situation that a factory, let us consider factory. Okay, so factory will have one warehouse where they will store all their stock. So you can consider that store as your buffer. So now producer will produce its items and store in that warehouse. Consumer will consume from that warehouse. So there is one location storage data structure which has to be common, that is your warehouse, and has to be that variable must be shared. It should be a shared resource by the producer and consumer. So now if the warehouse or the store can store only 100 shirts and the factory produces 120 shirts, then definitely this 20 shirts will be lost because it's now overflow problem. So every time factory produces something, the factory before it produces a shirt, it has to go and check in the warehouse if that much space is there in the warehouse or not. So you'll have to, every time producer produces something, before producing, it will have to check for condition. Okay, it will have to check that buffer, which is an array. So you will run a for to check in the buffer if space is there. So if your I is less than equals to 10, then your producer will produce a variable. Okay, so in this way you will have to write a code where you will declare a variable, let us say buffer of size 10. Okay, so your producer will produce and store in that buffer, your consumer will consume from that buffer. So if you have stored 10 values in that buffer and if consumer has consumed 2, then in the producer, when producer will try to produce something, then the buffer must be updated every time, because now the buffer, after producer had produced 10, the consumer must have, and the consumer have consumed 2, so now the buffer is updated to 8. So producer should be allowed to produce now 2 more shots. Okay, but producer must be stopped from producing after the value, after the size of the buffer is full. We do not want overflow to occur. Okay, and your program should also be able to produce and consume simultaneously. Like producer is producing first item, second item, meantime if consumer wants to consume, your consumer should be able to consume it. Okay, concurrently it should be happening because it is an inter-process communication. We studied that in cooperating processes. Okay, so this is what your program should be able to do. Is it clear now? कंज्यूमर के लिए अलग से, yes, yes, yes. In switch case, for, it depends upon you. While, how do you want to do it? And what is the comment? Right now, I've given you an aim. Okay, so that is implement producer and consumer, wherein one variable will be there which has to be shared by them both. So now, how do you implement that variable data structure? That's entirely up to you. Okay. Similarly, which loop or which conditional and iterative structure you will choose, that depends upon the way of your implementation. Mine aim is that a shared variable must be there, underflow should not occur, overflow should not occur. Okay, so you want to do it with switch, for, while, array, queue, what is it? It depends upon you. And as I said in last lecture, the implementation should be circular structure, in circular phenomena. By that, what do I mean is, so if this is the data structure, okay, and this is your buffer, let us say this is your buffer of size 3, buffer of size 3. You should be able to store it like this. You should move forward when it comes to storing. Okay, one if you have stored here. If new value comes, you store it in the next location. And if new value comes, you should store it in this location. Okay. When you consumer consumes, you should not consume from the last location. While consuming also, it should start from 0th location. And then it should move to the next location, next location. It should not be that you have stored here, you have stored it here, and consumer will consume 3. No. So if you will go for stack, see here, if you will go for stack, then we know that 1 will be stored here. If you will choose stack implementation for this one, then you will have to keep in mind. If you choose array, it's gonna be easy. If you'll do stack, then you know that 1, 2, 3, I told you it should be in circular fashion. That means now if because producer has produced 1, so it will be the one that will be stored at the bottom, and 3 will be the value stored that will be stored at the top. So now if consumer will come to consume, then 3 will be consumed first. No, that should not happen. Yet if you want to implement it using stack, then you will swap it out. You will pop, stack के भाषा में pop बोलते हैं. You pop it and store it somewhere. You pop another value, store somewhere, and then you pop this one and return it to the consumer, and then you push back 2 and 3. And of course, it becomes a lengthy process. So in implementation of producer consumer problem, we don't usually go for stack implementation. We either go for array, linked list, queue, like that. Because the implementation should be in circular fashion. Why? क्यों ऐसा होना जरूरी है? The reason is because if you will consume from here, okay, यहाँ पे करोगे, then you will go here, then the storing again, when producer produces, the storing becomes complex. So if we will store, if we will keep storing here, start from here, then after it is full, instead of going back, what we can do, we can go to the starting. It becomes easy to go back to the starting point, because starting in an array is always the 0th index. So if we will go back, we'll have to keep searching which is the next location that is free. So we do not want to make it complex. We want to make always in the implementation of the project, we always try to look for the simplest solution. So this way the solution becomes easier. So that does not mean you do not want to do, you cannot do it this way or that way. Yes, you can have your own way, but that should be the most simplest, and you should avoid the number of iterations, whether it is searching, sorting, or storing. It should be as minimum iteration as possible. Okay. So any more doubts? Okay. So others, Ram have cleared his doubts. So others, can I move to the next topic of the day, or should I, is there any doubts? Are there more doubts? I'm checking the chat box. If you have had any, you may write down in the chat box or unmute your mic. If it's clear, no questions, you simply write down no question or clear, or move forward. Yes, ma'am, move forward, so that I can start with the other topic. Clear? Okay. 1 or 2 more yeses are clear. Guys, 1 or 2, ek do jan. Okay, Subhas, girls. Okay, thank you guys and girls. Okay, so I told you in the last lecture that we have completed with the first unit. Okay, so we have completed with the first unit. Now I wanted to start second, then I just thought about, okay, it may happen. So some of you may choose to implement producer consumer problem with threads. Okay, it is also possible. So I thought, but your thread is in the 4th unit. So if I will teach you threads at the end of the semester, then you may not be able to use it in any of the programs. But we always have some curious students in every batch. So if there is anyone who likes to do some what do we say? Who likes to do some test, who likes to play with programs, who likes to try different methods, then you can also go for threads for producer consumer problem. Okay, producer consumer problem, remember, it implements cooperating process. Yes, it was asked in one of the competitions. Okay, competitive exam, it implements cooperating processes. Because if you will see here, two blocks are dependent on one another. We usually implement producer consumer problems with two different programs. Alag alag hota hai instead of one. If someone knows how to write two different processes, how to make them communicate with one another, then you can also go do it that way. Those who is familiar with network programming, socket programming, if you have done it before in your bachelor degree, and if you're familiar with the classes like buffered reader, scanner in Java, of course in Java, then you can go for you can do producer consumer problem by choosing socket programming technique. Then you will be able to feel it more like a producer consumer problem. And those of you who do not know that, you can simply go for one single program. Okay, one single program with producer and consumer in it, and you can make them communicate with one another. So this is the second way. The third way is with the help of threads. So in today's lecture, we are going to discuss thread. Okay. Okay. So now we are going to discuss today threads. Okay. Thread. So now what is a thread? A thread actually is it's a flow of program, and the main purpose is, you can also say a thread is a sub program, okay, or a sub block inside one big program. For example, if this is my entire program, then you can declare different blocks as thread. So if you declare different blocks as thread, this is my thread 1, this is thread 2, this is my thread 3. In the future, you are in semester, I think probably in your third semester you have Java. Okay, so there I'll teach you how to implement threads, how to do multi-threading. I'm not C or Java. So when I'm teaching Java, I'll teach you in detail how do we do multi-threading. Okay, so for C, I'll give you the theoretical aspect for OS. Okay, so how does it happens in C? You can look for it, or if you had C in the past, then you must have already learned the way to implement thread. I think you have already been taught P threads. Threads to padhate hi hai C mein. Okay, so you can just the thread that you learned in first semester, you can just get an overview from this lecture and you can implement it. Okay, so now what happens in thread is this is single program. Let us call this program as pgm1.c. So if this is not a thread based program, then the implementation will go like this from top to the bottom. Okay, so it will be one single flow, each line will execute one by one. But now if it is a thread based program, then we will have different blocks of code declared as thread. And what happens is all this thread will execute concurrently, just like your cooperating processes. That means now in this case, it will not be a single flow, rather let us say there will be 4 flows. One flow will be the main program that will be executing at the background. Along with this main block, your thread 1, thread 2 and thread 3 will be executing simultaneously. Just like the way if you have 3 processes, P1, P2, P3 in your main, by now we know that when we have multi-processing concept, multi-programming concept in our computer system, and if we have 3 processes in the main memory, that means 3 processes are executing simultaneously. Similarly, if you have implemented this process 1, if your process 1 is this program 1, okay, and if you have implemented this program 1 with 3 threads, that means along with multiple processing, you will also have one program who will be having different threads and that will be executing simultaneously. Okay, so along with the main, this program will have 3 blocks that is executing concurrently. Okay, so because of this reason, we call thread as we call thread as LWP. This was again asked in one of the competitive exam. Okay, what does LWP stands for? LWP stands for lightweight processing. Lightweight processing. Why is it called lightweight processing? I will explain later. But remember that a thread is a subblock in a program that executes concurrently, that executes simultaneously. If you have one thread in your program, that means there will be two blocks of that program that will be executing simultaneously. One is the main of that program and another is the thread. And if you have three threads, that means there will be four sub-blocks of this program that will be executing simultaneously, that are three threads along with the main. Now, just like your process, okay, just like your process, your thread will have a thread ID. Otherwise, if each of the thread is not given an ID, then how will the compiler understand what are the three or four different blocks that is executing simultaneously? So because we want to make the identification clear and we want to get clear output, to each thread, a thread ID is assigned. Thread ID is assigned. So if this is first thread, it will be given thread ID 1, thread ID 2, thread ID 3, just like your process ID. For this one, we have PID 1, 2, 3, similarly like that. Okay. So it will have a program counter. Each of the thread will have a program counter. Okay. See, let me write down CU anti count, because we need to know if, let us say, this thread runs for 20 number of times. It has a for loop which goes from 1 to 20. And while 1 to 10 was finished executing, the execution of thread 3 begins. So we'll have to store it that the next count is from the 11. Okay, so just like the says, we have to make sure that we give count of the thread, and to store these values, we need a register set. Okay, the register set and a stack to store the values. This just like PCB hota hai to store the value of the process. Similarly, a thread will have a stack to store its values. Okay, so now let me tell you, why do we call thread as a lightweight program? You'll find this in the book that you're referring. Okay, you'll find this picture in that book. Okay, so now on this, this is a thread multi-threaded. Okay, so this is the diagram. Okay, so now this is my okay, what we can say is, okay, so when we say a single threaded program, that means it is one, the program that you have been writing so far, it is a single threaded program, because even if you will not declare any thread implicitly, that means that program will have one thread, and that is your main function. Okay, jo main likhti ho, even that is one thread. For example, if you will buy a string of pearl necklace, okay, so if you will buy a string of pearl necklace like this for your Mother's Day gift to your mother, so let us say this is, so this pearl will be beaded together by one thread. Okay, so we do not call it as one line pearl. Okay, we simply call it as a pearl set. So now if you will buy a pearl necklace with two threads like this, then we call it as a pearl necklace set with two lines. Okay, we call this a pearl necklace set with two lines. Similarly, even if it's a regular program, then we call it as a single threaded program. And if we have multiple threads, then we call it as multi-threaded program. Okay, so now we have already seen the PCB, process control block. So this is one process. Let us say this is one process. So we have already seen the PCB in the, I think, lecture 2 or lecture 3, that it has a code, a data, a file, a registers, a stack, and this is the main thread. Okay. But now, if I have process or a program which implements the multi-threading concept, then how does it look like? It will be one single program only. एक program ही है, but now in this program there will be certain values of the stack or array that will be shared by different threads, and there will be certain values that will be individual or that will be limited to the thread. For example, in this program P1, okay, while writing this sorry, let me write down P2. In this program P2, you can see here there is one single code. That means एक ही program है, and it will have that many sets of variables, that is your data, and whatever files you want your program to manipulate, that many files will be there. Okay, so now if your program for you, let us say it is a producer consumer problem, in that case you will have two explicitly defined threads, okay, and one main thread. But now producer, consumer, and the main thread has the buffer B, let us say. So this is my producer thread, this is my consumer thread, and this is my buffer. So now this will be the main function, this will contain the main. Okay, so in the main we have the data variable data, okay, so which is the buffer. Okay, so now it has this main program has all the codes for this code part will be executing the consumer block, it will be executing the producer block, and whatever files you need, that will be there as the main program. Now this consumer will have certain values that will be restricted to this consumer. For example, the condition which checks the underflow situation. Okay, so all these will be stored somewhere. This thread will first be given a thread ID, let us say 1. So all the values that is restricted to this thread, that means all the local values that this particular thread needs to execute, will be stored in its individual value register and stack. Similarly, the same thing will go for your second thread and all the other things. So I think it was 2019's net exam or 2020. You can check question paper, या तो 19 or 18 or 20, I'm not sure. They had asked the question from here. Okay, so in a multi-threaded program, what are the set of values that are being shared amongst different threads? So your option were code, data, files, I think it was register or stack. So you were supposed to say what are the values that are shared. So the values that are shared is your code, data, and files, and the values that are not shared, that are restricted to each of the thread, is your register and stack. So this is how they ask questions. Okay, so this is your thread. So now let me tell you, why do we call thread as lightweight program? Now, if it was just consider a situation, it was a multi-processing system. Now, just consider it was a multi-programming system. Okay, this was multi-programming. Then we know that multi-programming system, each of them will have different PCB. If this was my process P1, if this was my process to P2, and this was my process 3, that means I will have 3 PCBs, 3 process control block. Okay, so that means three very complex data structure has to be stored, and each of this data structure has to be mapped to their respective process. That means pointers that will point to that particular location, and that particular location will be storing in a stack set of values where continuously you'll have to perform push and pop operation. So unnecessarily you'll have to perform so many times context switching. Okay, but now if you will say thread, this is one single process, so you'll have, instead of three, you will have only one PCB. Okay, you will have only one PCB. Inside this PCB we will add some more values, but we will have to, if we want to store this data structure, it is just one complex data structure instead of three. And also if we want to go to this particular, we'll need only one pointer to point to this particular location. And every time we perform push and pop, we have that same location where we want to perform different things. This is the reason we call thread as lightweight programming. Okay, so we call thread multi-thread as lightweight programming, LWP, and process as HWP, multi-programming or multi-processing system as HWP, heavyweight programming, because it needs individual PCB, storing individual PCB in different location, a table to map. If I have 3 PCB, I will have to maintain a table where this will remember. Now the job of this table is to remember where have I stored PCB1, where have I stored PCB2, where have I stored PCB3. But in case of threads, multi-threading, we do not need this storing at all. That means space is saved. Also, we have to create a table. So we don't have to create a table. If I want process 2, in the PCB, I have to search where is process PCB2 of process 2. So we do not need searching. This entire job related to this table is eliminated. Okay, so no searching is required in case of LWP, lightweight programming. Okay, but everything, if it's related to multiple processes, all of these are required: mapping, tables, storing PCB, individual PCB, and your pointers, individual pointers. But in case of threads, we need only one pointer because it's just one PCB. So is the concept of thread clear to you all? Any doubt from the threads? If it's clear, write in the chat box. If it's not, please write down in the chat box. Students, is it clear? Okay. Okay, clear. Shivam, not clear. Pinju, okay. Shivam, Pinju, what? From where should I explain again? शिवम एंड पिंजू, आप लोग थोड़ा माइक अनम्यूट करके बताइए मुझे. Were you there in? Have you attended the lecture when I taught PCB, process control block? When I explained that, were you present? Shivam and Pinju, please unmute your mic. That will be faster. Okay, that was Shivam. Pinju, were you present when process control block, processes, multiprocessing was taught?
No, ma'am.
नो, देन पिंजू, फिर आपके लिए मैं मेहनत नहीं करूंगी, क्योंकि आप अगर नहीं थे तो फिर ये तो आप समझोगे ही नहीं. ओके, इसको समझने के लिए पीसीबी को समझना जरूरी है. तो शिवम, नाउ बिकॉज यू आर प्रेजेंट ऑन दैट डे, from you have written not clear, so which part should I explain? The entire part or some specific part? Okay, So I am going to open the page where I have drawn the diagram. So इसको देख के आप chat box में लिखो entire और some specific, कोई भी यहाँ से specific है तो chat box में लिखो, मैं वो explain करूँगी फिर से. अगर सब explain करना है तो लिखो entire. Now I'm going back to the chat. Entire map. Okay. So Shiva, uh, here what we are comparing is we have one more context called as your multi-threading. Okay. So with the help of multi-threading also, we can enable different blocks belonging to that same code, okay, to execute simultaneously, because you're not able to understand it theoretically. So let me explain it with the help of an example, okay. So when the idea of multi-threading was proposed, that is the time, that is when the gaming world started gaining the gaming world, or even these animated movies, cartoons and all were started becoming more interesting. Okay, why? Because when we talk about cartoons, animated movies, games and all, then we know that it is entirely written with some programming language. Okay, now even a 3 or 4 year old would say that any gaming that they play is programmed, वो entirely program से लिखा हुआ है. But we know that program flow starts from one point and each line executes in sequence. So when in bachelor's you might have studied programming. What is a programming? It is different lines of statements written using particular language, where each language will execute one after another. So that means if I have each line executing one after another, and if this is your cartoon movie, Tom and Jerry is my favorite cartoon. Agar aapko you do not know Tom and Jerry, then you can consider Chota Bheem, Bada Bheem. If you do not know Chota Bheem, Bada Bheem, I think you know the Ice Age. Okay, so Ice Age, that I'm very bad with remembering names. So we have that one funny character which is present in every series of Ice Age, because if whom the Ice Age apocalypse is shown to happen. So there you can consider any of these animated movies or even game. Those of you who know PUBG, those of you who have played different types of games, you know that if I have any entity here, let us say this is my tomcat. Okay, so when cat is moving on this side, and if there is a window here, okay, so there is a window here, and if cat is moving on this side, then this window should move on this side. If it is moving towards north, the window should move towards south. So there should come a point when cat, if this is the wall of the house, and by the moment Tom has hit this wall or with his head, there should be no window at the background. But now, and all of these are one single program. It is not many processes. It is one single process P1. So now if I have one process P1, and while cat is moving forward, this block is moving backward, that means कोई भी regular person बता देगा कि these are two different sections. And while this one is executing, this block of code is also executing, because it has to move backward. Program के पास intelligence तो है नहीं कि it says okay, now cat is moving backward, I will move cat is moving forward, I should move backward. Program will not do that. You have to make that window move, like for loop 1 or 2, you have to make it happen. If you will not increment the values of for loop, it will get restricted to a particular value. Okay, so that means we have two different blocks belonging to that same code executing simultaneously. So how do we do that? We do that with the help of threads. So what do we do it? We declare this part of the code as thread. I don't know in C. Okay, so I don't know in C. So I'll teach you in Java. How do we do it? Okay, I don't do C programming, but I teach you. Okay, so let us, we know that any object-oriented programming, we declare a class. So let us say class A. Okay, so we have something called as thread class. So I will write down extends thread. So that means now I have declared this class as thread class. So whatever block of code I will write here inside this one, if I write for loop, now this class will execute along with your main function. Let us say your main function prints ABCD and your this class prints 1, 2, 3. So in the output window, along with जब ABC print हो रहा है, at the same time even 1 to 3 will be printed. So that means we have two different blocks of code that is executing simultaneously. So that is your thread. Okay, sorry, that is your multi-threaded. Here by single threaded we refer to the process, one single process. So what is the commonality and what is the uniqueness of single process and multi-thread that I'm explaining? Okay, so if it is a single process, okay, if it is a single process, if it's a process, it will have one thread, that is the main function. It will have one register, one stack, one file, one data, one code. That means it will have one PCB. Okay, so it will have one PCB. So now let me divide this into like this. Okay, so actually this is two parts. So now I have process P1. So now if you have another process just like this, you will have one more. If this is your PCB, process control block, represented diagrammatically. In earlier lecture, I taught you PCB with the help of a stack diagram. Here we are representing it with the help of a diagram. Okay, so these are the entities that were there in that diagram as well. So now if I have another process, I will have another PCB like that. So let us say I have three processes. So I will have three PCBs like that. So three location to store this PCB, three complex stack where we will have these values. Okay, so now we will have we'll have a table that will store the location for this three PCB, because every time in the CPU processor, if process P1 is called, I need to find out where is this P1 in my computer. So I will have a table which will store the location of this PCB. So I will have a pointer which will point to that location. So if three process, that means three PCB, three entries, three rows in the table, store this table itself will take some location, pointer to map this one to the current location. So that is if I have multiple process, and this is one single process. एक process के पास इतना value होगा. So now instead of doing three process, if I have one single program which will have multiple threads, then see here these many informations are saved. This if three PCB, that means three code, three data, three files, but here three threads, yet one code, one data, one file, because this belong to one single program. Just like this one, see here, this is Tom with the window, one single program. So if you had Tom here, if you have window here, so you would have two PCB and each PCB would have this one. But now I have one process here. So it shares code, data and files, attributes. Okay. But each of the threads, each individual threads, this is suppose Tom, this is Jerry, and this is the window of that program. And this is the main program here. Okay. So now Tom will have its own register value. It's running. So it has to store the value. Okay. Running. So now similarly, this is Jerry. Where is Jerry right now? If somewhere in the background. So it has to store its current value. Okay. So where is this window? This window is here. So now while Tom is running this side, obviously अगर यहाँ पे cat है तो यहाँ पे mouse होगा. So let us say this is my wall with a hole where the rat will go inside and hide. So as Jerry move forwards, Tom should always move forward and the window should move backward. These are the three blocks of code that execute simultaneously when one single program is executed. Okay, but because all of these three blocks of the code will have some local values that is specific to them, because the feature of Tom is different, the feature of cat is different, and the feature of window is different. So these are some values that are specific, but this background if it's a red color square background, then this is same with all these three window, Tom and Jerry. So this is where what I mean by code. Okay, something that's common is your code. For example, the buffer that you have created, that's the data. Okay, and the entire program, the main function is shared by your consumer and your producer. Okay, so that is your multi-threaded. So because of all these reasons, if we are to talk about thread, in if it's a process, it's an instance of execution. एक instance से it will execute, but thread is a line of execution. Each line will execute individually, but in a process it's an instance of execution. And your thread is smallest, okay, scheduling entity, but in process, okay, you have each individual process executing simultaneously. And because process are individual entities, process 1, process 2, process 3, we need to perform context switch. If in the cpu 1 is there, now if 2 wants to go, now we have to bring this, we have to context switch, take out this 1 from cpu and send it back to the main, and this 2 will context switch from main to the cpu. So in your multi-processing, you need context switching, but in multi-threading, because we are in that same program, so we do not need to context switch. What that program is already loaded in the cpu. So if I want to run second block, we need not pull it back and put it back forward. No, we don't need to do that because it's already there in the cpu. Okay, and also each process, if I have 3 programs in your calculator word file and your browser in your main memory, this one single program, but it has 10 tabs, means 10 threads are there. 10 threads here. See here, this is your browser. I think you can see it. So this is your browser. When did I lose you guys? Guys, when did I lose you? How far had I taught you? I didn't realize that my network was off. Okay, if my network goes off because I was continuously talking, okay, मैं बोल ही रही थी, so, and if my network gets locked, I don't realize because when I am in the paint window here, okay, when I'm here, I cannot see you guys. मेरे browser में कौन है, मेरा network on है off है, मैं देख नहीं सकती हूँ. I can only see that window. So you just put text me in the group, WhatsApp group. मैं continuously check कर रही होती हूँ आपके OS का group. So आप वहां पे लिख दो कि मैम आपका नेटवर्क चला गया है. So now I have already taught everything and I don't know where did my network go. So can someone tell me कहाँ तक आप लोगों ने सुना? Guys, can you tell me how far till when my network was on? अच्छा, okay. Thank you then. So now where was I? मैं थोड़ा recall करने की कोशिश करती हूँ. मैं flow में थी. मैं क्या बोल रही थी? 1 2 3 क्या ड्रॉ किया था मैंने? Okay, so when it's about multiple processing, that means this is your main memory. Okay, this is your main memory. I told you that there are multiple programs in the main memory. But even if it's a multi-programming concept, in CPU at a time, I had been constantly telling you there will be only one process if it's a one core system. Okay, but in if it's a multi-threading, then we know that it's a single block of code. Okay, and we need not that same program is there in the CPU, and we just need to move upward and downward from of that same program, so we need not perform any form of context switching. Okay, so this is your multi-programming. Ma'am, your voice is breaking. Vomit. Okay. So now I don't know. I think it was Shivam. Na Shivam, आपने बोला था clear नहीं हुआ. So Shivam and Pinju, is multi-threading, the concept of threads, the concept of multi-threading clear to you all, or should I repeat something once more? Is it clear? Shivam, clear. Okay, girls, is it clear? If there is anything that's not clear, you can still ask me. ओके गर्ल्स कोई तो भी एक लड़की मुझे बता दो कि इट्स क्लियर Rashmi. Okay, thank you guys and girls. Okay, so why do we perform threading? The benefits of performing threading is responsiveness, because there is one single program and different blocks that is executing simultaneously. So if we want it, if we want to want one block to, if we were executing one block and we want to move to other block, then we need not take it out from the CPU and we need not bring something from the main memory. Everything is there in that program itself. So the responsiveness is very high. The time that is taken to perform some, the time that is benefits can, benefits of threads. Okay, let me check group. Okay, so benefits of thread is it's the rate of responsiveness is fast. Responsiveness is fast. Okay, it's very fast. Whatever we ask it to do, it's very fast. Okay, so second is your resource sharing. You're performing resource sharing. For example, your buffer. Okay, in your producer consumer problem. And obviously, the most important fact is your economy, because we are economic, because we require only one PCB, one CPU time, and only one stack, no mapping, no multiple pointers, no tables. Okay, no a lot of entries in the table, so it is comparatively economical than your process. Okay, so I've already taught you what is a thread. Okay, what is a multi threading, and I've also taught you multi-processing. So I've also given you the difference with the help of diagram. Okay, so you can prepare notes on multi-threading and multi-processing by yourself, because this difference between multi-threading versus multi-processing, not directly, in different ways, like context switching is required in multi-threading, yes or no? It's obviously no, we do not need context switching. Okay, so such types of questions based upon the difference between these two have been asked multiple times in the competitive exams. Okay, so you can, I've already taught you that, so you can just prepare a notes on your own. Okay, so now if these are clear, so I'll move to the next topic. Okay, so now there are different types of threads. Okay, so there are different types of thread. One, we call it as user thread, and the other we call it as kernel thread. I think by this, by writing this, you are already clear with the definition kernel thread. Okay, one is your user thread, another is your kernel thread. So now what is a user thread? User threads are supported above the kernel. You know that what is a kernel? We have learned in the first or second lecture. Your operating system, your this is your OS. Okay, so your OS is a layered structure. OS is a layered structure. At the bottom of the or at the center, at the bottom or at the center of your operating system is the kernel. Okay, so other part is the OS or the base, or it has different name, the OS, the wholesome of the OS, the base of the OS, or like this, which we can use it. Okay, right now the paint 3D is running in the base of the operating system, or also it is called as layer 2 of operating system, and kernel is also called as layer 1 of operating system. Okay, so when we do something, we do not get to access the kernel. Okay, we access actually the layer 2. Okay, so this is your layer 2. Remember, this was also asked in one of the competitive exams. So this is your layer 1. Operating system is a layered approach. Always remember, it is a layered approach. It is asked whether it is a stack approach, tier approach, layered approach, none of the above, all of the above, then you have to remember that this is a layered approach. It has two layers, layer 1 and layer 2. Layer 1 is the kernel and layer 2 is given different names. Okay, different book, different researchers gives different names. So layer 2 is the OS, layer 1 is your kernel, and we, the user, cannot interact with the layer 1 or the kernel. We interact with the OS. And remember, in one of the lectures in the past, I used the term system call. Okay, system call. When we do something, layer 2 invokes a system call, and this system call goes to the kernel, executes whatever request, extracts from here and gives it back to the layer 2, and layer 2 gives it to the application, that means to us. So we don't get to access the kernel. Okay, so now based upon these also, there are two types of threads. One is the user thread, another is the kernel thread. So now this user thread is the thread that we write, like in as I showed in Java, we do class A extends thread. So this is the thread that we have created, user have created. I will give you one aim. So your next aim is to implement multi-threading in C. Write down the aim. The first aim is implement producer-consumer problem. The second aim is to implement multi-threading in C. Okay, so for that you will use the thread p threads. Okay, so you will use p threads. So now when you will do p threads, one thread is created. When you will do one more p thread, two threads are created. Okay, so when you create a thread using p threads in C, thread class in Java, C++, I don't know, okay, threads in Python, that means you are creating a user thread. Okay, but now see here, I am doing this one. I'm also going to the folder, I'm going to the browser. Okay, I'm coming back to the pane. So I'm constantly moving from here and there. Okay, so to handle all of this, operating system creates thread. Okay, to handle all of these different situations. Okay, the thread that the operating system creates by itself, that we cannot do anything with, that comes inbuilt, is called as your kernel thread. Now kernel threads are supported directly by the operating system, and your user threads are supported above the kernel, yahan se upar. Okay, so this from below here your kernel operates it. Okay, so above here we user operate it. Okay, we operate it above the kernel, and we write the user thread by ourselves. Okay, so now we have this p thread, POSIX p threads in C. Okay, that is supported by the Windows operating system. Okay, so these threads are also specific to operating systems. Okay, so different operating system can identify different threads. Okay, so clear yahan tak what is a thread, what is a user thread, what is a kernel thread, the layered approach of your operating system. This is a different topic which I have taught here only. Already पढ़ा दिया है, so I will not taught it in a different topic. I have explained it with the help of this one. So आपको notes बनाते हुए you'll also have to prepare layered or operating system in detail करके you'll have to study the layered approach. In the center we have the kernel, above we have operating system, then system call we have already discussed. So the difference between user thread and kernel thread. Is it clear till here? If any doubt, please write in the chat box. If it's clear, write down clear so that I can move to the different types of threads.
Clear, ma'am.
Thank you. Others? Okay, Pravesh, Shivangi, okay. Okay, so now let me go to the other topic. Now the second topic is different kinds of thread. Okay, the different multi-threading. As I always tell you, while I'm writing, take a note of what I've been taught so that in exam you'll know what are the topics that you must study. Okay, the multi-threading models. So there are different multi-thread. When we have more than one thread, if you the program that you have been writing till date, you might have done data structure. You might be doing data structure using C. In first semester, you have studied C and implement and also done the C programming. Whatever programs you have done so far, it's a single. It's a what do we call it? Okay. So what do we call it? It is a process or a single threaded program. But multi-threaded program is when in the program you create a thread by yourself. That is called as multi-threaded program. So this multi-threaded program is of many type. One is your many to one model. Okay. One is your many to one model. Okay, so what happens in your many to one model is, okay, what happens in your many to one model is we user create multiple threads, user threads. Always remember, we user create multiple user thread. Let us say you have created 4 P threads. Okay, 4 P threads. So that is the user created threads. But operating system is such that it can handle only one thread at a time. Okay, so it can handle only one thread at a time. That means the layered approach has only one kernel. Okay, it has only one kernel. That means many user thread, when at the end it is mapped to one kernel thread, it is called as many to one model. That means let us say that you have one process wherein inside one process you have four user created. Okay, so theoretically these 4 threads should be executing concurrently. So when this execution happens with the help of kernel, let us say when this at one go we have sent at least 2 threads for execution. When these 2 threads are sent to the kernel, but we have only one kernel, that means it will execute only one thread at a time. Okay, so this is called as your many to one model. Okay, so now is many to one model clear before, because I need to clear and make sure that many to one is clear. If it's clear, then the next it's easier to understand. Is it clear? Many to one model?
Yes, ma'am.
Thank you. So now we
Yes,
have
ma'am.
to make sure that, okay, thank you. Now there is a problem with this many to one model. Okay, there is a problem with this many to one model, and that is When we say thread, okay, now this one you just hear it theoretically, because practically, because this is an operating system class, so I'll not be able to show you, but in future in Java I can show you this, because that is a language based. While teaching multi-threading, I'll also be teaching programming, so just listen to it carefully. So if you'll find it somewhere, you will be able to feel it. Okay, when we talk about threads, okay, thread comes with its own set of various methods. Thread has its own various methods, okay, because here we have, when we say multi-threading, we have multiple threads which are executing simultaneously. What happens in many cases of multi-threading is, let me think of an example, okay. Mm, Okay, so yes, let us say this is Tom and Jerry. Okay, so there is a clock now. There is a clock now, and according to this clock, it's 12:15 now. Okay, so here is the Tom. Here is the Tom. So Tom moves from here to towards wall. Okay, so this is one thread below thread one. This is your thread two. Two threads running simultaneously, but this is one single process. Okay, so when Tom will have moved 10 steps forward, let us say by the time it reaches here, the time in the clock, every one step will not take 1 minute. So if Tom has taken 15 steps, the clock should not be showing 12:30. Okay, the clocks, let us say Tom takes 15 steps in just 1 minute. So it should only be 16 minutes. Okay, so that means the speed at which this thread runs should be 15 times lesser than the speed at which this thread runs. So when this thread have executed 15 number of times, it should execute only once. That means while this thread is running for one time, okay, sorry, 15 times, it should be sleeping for 14 seconds. Okay, so to do such things, we have a method in thread called as sleep, that makes the thread sleep for the duration of time you give that as parameter. So let us say 10, then it will sleep for 10 seconds. So now, if this Tom can move only after, let us say this is my cat, Jerry. Okay, so this is my Jerry. This Tom will move towards this wall only after this Jerry comes in between. That means for this thread T1 to move, it has to wait for Jerry to come. So it also has wait method. Similarly, like this, thread has various inbuilt methods to do so many things. Okay, so why was I telling it? मैं आपको ये बता क्यों रही थी? Acha, okay. So I was telling you this, there is a problem with many to one model, and it is, if any of these threads, if any of this one thread calls the block method of thread, or in C it may be block, in Java we call it as kill thread. Okay, kill thread. In C it may be block or something, you can check for yourself. So if any of this, out of this 4 user thread, if one single thread calls block method, then this entire thread will be killed. So that is one problem with the many to one model. Okay, so I hope by now many to one is clear. So let me explain to you other type of thread. So you have studied what is thread, what is the difference between multi-threading and multi-processing. We have also found that there are two types of thread. What is a user thread and one is the kernel thread. Okay, and again in multi-threading, we have found that multi-threading has different models. Okay, so multi-threading has different models. The first model in multi-threading is many to one model, and the other is your one to one model. Now, because I've explained many to one in detail, so now one to one I will not explain with the help of sub programs or examples with respect to programmatical aspect. Rather, I'll explain just with the help of diagram. Okay, that's why I asked you if many to one is clear. So after I just give you the definition, if it's not clear, any question pops up, you just ask me that. Okay. So now what happens in many to one is it's pretty simple. You might have already been able to guess it. For each user thread, we will have a for each user thread, okay, we will have respective kernel. Okay. So now if the system has two kernel, if the operating system has two kernel, then we can have two user thread running simultaneously. So if the system supports three kernel, if duplicating kernel is possible, or if the operating system has multiple kernels, we can have one more user kernel. That means if any of the user calls the block method, if any of the user calls the block method, only that thread will be killed, but other thread will continue to work. Okay, so now for this one, I'll not explain with programmatical aspect. I hope by now you'll be able to clear or connect. So clear one to one and many to one. Yes, if clear, yes. If not, tell me where do you have the problem, user what, I'll explain again. Students, is it clear? Thank you. Others, only one person continuously interacts. Other also, please say yes or no. Madan Rizal, I've never heard from you.
Yes, ma'am. Clear.
Subhash Shetty, one to one, not clear. Okay. I will explain again. Bhumi, clear. Okay. Okay. Madan is also clear. Thank you, Madan. And Ridiman, is it clear? Ridiman, is it clear? Okay. Okay. Thank you. Thank you. Subhash, you're not clear, right? One to one is very simple. One of the simplest thread. Okay. Let us say, okay, one to one means there will be one user kernel, one user thread, and there will be one kernel. Okay. And if it's an operating system, okay, that does not mean we cannot have multiple user thread. Okay, yes, we can create multiple user thread, but the end it will be many to one model. That means we will have created multiple threads, but there is only one kernel. That means by implementing a way of multi-threading, we are actually at the kernel level, at the operating system level, actually only one block of code is getting to execute. Okay, but one-to-one model means sometimes what happens, one-to-one model is implemented in two ways. Okay, one, when we buy the operating system, it has multiple kernels. The operating system is such that it supports multiple kernels. Okay, so and according to that, the cost of the OS also increases. Okay, so if the operating system have 5 kernels, and if you are creating 5 user kernel, that means actually even at the kernel level, all the 5 user threads are executing simultaneously. Okay, all of them are executing simultaneously. And other way it can be implemented is every time user creates different threads by implementing the concept of multi-threading, and if the operating system supports this idea, then what does the operating system does is, if it has only one kernel, as the number of multi-thread increases by the user, it creates a duplicate copy of the kernel. It creates a duplicate copy of the kernel, so that each user will have their own kernel to execute. What is this user actually? It's a block of code. Okay, it's a block of code. That means block 1, block 2, block 3, block 4, block 5 is simultaneously at a given point of time concurrently executing at the kernel, because at the end of the day everything executes in the kernel. Okay, the kernel system call se hota hai. So this is what is your one-to-one. Now because each user kernel, because each user kernel has its own, each user thread has its own kernel. If you will block or if you will kill this thread, that other user has its own kernel, the third user has its own kernel. That means even if you will kill one user thread, other user thread will continue to work. Okay, so now is it clear, Shivam? Subhash?
Yes, ma'am.
Subhash, is it clear now? Subhash, am I audible? Subhash? Where is Subhash? Okay, thank you. So now the third type of model is now the third type of model is many to many model. So now I've seen in my past, from my past experiences, I've seen students getting confused with one-to-one and many-to-many at the time of exam. When I'm teaching them, it seems clear to them, okay, but at the time of exam, they get confused. So if you have a pen and a paper, just write it in your language quickly so that it becomes helpful in the exam, okay. So let me explain many-to-many. Many to many is very simple. It is much like one to one with one difference. That is, we can have, let us say, I have many, in many to one model, I have many user kernel, but I have only one, uh, I have many user thread, but I have only one kernel thread. One to one, for each one user thread, I have one kernel thread. That means if I have 4 user thread, if in a competitive exam or in a classroom exam you're asked, the operating system implements one-to-one multi-threading model, and now the user has created 4 user thread. So how many kernel thread will be there if one-to-one model is implemented? Answer is simply 4. So now question comes like this: if in US Sushmita, or if in India in IIT Sushmita is writing a program in competitive exam, they just make the question look complex. It's usually simple. Okay, if Sushmita studies in IIT or Sikkim University and she is writing a program, her process starts to execute wherein the process has 5 threads, but the operating system implements many to one model. So the number of kernel thread is 1, 5, 6, none of the above. Simply one, because it is many to one model. The operating system implements many to one model, and many is the user thread, one is the kernel thread. Okay, so one to one model, one user thread, one kernel thread. If 5 user is given, user thread is there, then there will be 5 kernel thread. So many to many is okay. So now if I have, let us say, 4 user kernel, if I have 4 user thread, and I have only three kernels. Let us say my operating system performs has only three kernels. Then it has many user, many kernel, but the number of user thread is not equal to. The number of user thread in this model is not equal to the number of kernel thread. I may have three kernels, one user, two user, three user, four user, or I have more number of user, less number of kernel, more number of kernel, less number of user. For example, if your program you have created only two user, but I have three threads, kernel threads. Okay, so then also it is many to many. Now you have created four user threads, four p threads, but your operating system has only three kernel threads. Then also it is many to many model. Okay, so these are the three types of models. Okay, these are the three types of multi-threading models that we have discussed today. If there is any confusion, ask me. If not, I would like to move to the next topic. Is it clear, students? Please write it down clear, or if there is any doubt from any
Yes.
topic that has been taught today, just ask me. Even if I have to go back like multi-threading, multi-processing, anything. Clear, clear, clear. Okay, thank you everyone. So there is the second topic is a small topic. Okay, so we will in future also we will be studying this topic, but right now allow me to give you just the definition signal. Okay, so there are various smaller topics that we have studied so far from where question comes, but students often tend to ignore this smaller topic like signal, context switching, okay, context switching, dispatcher. These are the smaller topic that we have discussed so far, but which are extremely important, extremely important when we talk about operating systems. So you should always remember these words whenever time has come. Apart from just explaining the definition, these two have already explained the definition, but every time I can use this word, I have been using it so that the idea of this becomes clear to you. Okay, this I have been continuously using it. This I've used it for 1 to 2 number of times. Try to remember the definitions and remember their purpose, because direct questions have been asked 2 or 3 times based upon their definitions or based upon their operations. Okay. The signal, I'll give you the definition today, but unlike context switching and dispatcher, I will not be able to use these words as of now. In future, there is something called as Peterson problem. We implement multiprocessing with different ideas. Okay, I will be studying 3 to 4 smaller algorithms. That time I will be using the term signal, but I'll not define that time. Okay, so remember these words. So now, what is a signal? Okay, so a signal is a small topic. It is actually used in your Unix systems. Okay, and it is used to notify a process that a particular event has occurred. Like if you are executing a process and you want to tell them that particular event has occurred, you will use the signal. For example, let us say your process was executed. Let us say you are writing your assignment in Word file, and now you have to print it and submit it. So you wanted to print something and you go to the printing shop. You tell them, please print me this file, and then they will tell you, they will put your pen drive in the computer. They will give the print command, but they'll tell you wait for some time because the machine is printing something. Okay, so now you have given the print command, but your file, okay, your resource is in your pen drive, but that resource is waiting for your first print command to finish its task. When it's done, the printing printer gets free and you are given a signal. So it says that your printer is now free. So now if you do the same thing, like you given some print command but the paper gets jammed, it gives a signal. An event has occurred and it gives a signal. So when resource is free or if resource is occupied, if there is something with the resources, and that means there is some problem or there is something with the some event has occurred in the processor, then we use signal to notify that there is something, some event has occurred with the process. That is called as your signal. Okay, so now signal is of two type. Signal is of two type. One is your default signal. What is your default signal? Default signal handler. Okay, so that means this is the signal that is handled by the operating system, like problems with printers, paper jam, unavailability of paper, this that. Another is the user defined signal. For example, you are performing some sort operation. Okay, let us say your data structure is an array wherein you have stored values from 1 to 20. You want to find 10 in that array and want to print it. So when that 10 value is found, the for loop must stop and a signal is given to go for, say, next line may it will stop, you will search, you will stop, you will print. Okay, so it is your user defined signal. An event has occurred in the process, that means we have found the value and then we print it. Okay, so these are the two types of signals. Okay, so is it clear? Till now all clear, ma'am? Okay, Rajesh, so now is signal and different types of signal clear? Okay, so now tell me, do you have capacity to study for half an hour more, or should I stop here? Can I continue or should I stop here? Ma'am, let's stop for today, okay? So it's only from Bhomik. Bhomik, I will wait for your fellow friends. If I'll get more stop, then I'll stop. If more, yes, we can continue, then I'll continue, okay? So others, please give me your feedback. Should we stop here for today or should we continue? Okay, Rizwana, thank you, and thank you, Bhomik. I'm stopped. Okay, okay, okay. Now I'll stop. So just allow me to check if Google Chrome has taken your attendance or not. Please do not exit because it did not added your attendance itself. So I'm going to do it. So if you say jitna abhi those who are present, their attendance will be recorded. So please do not exit as of now. Wait for some time. Okay. So in the meantime, let me note down the aims that I have given so far. Okay. So yesterday the aim was to implement concurrent process execution for producer consumer problem. Okay, this was the one that I've given you. Their second aim is to implement, take down the second aim. I think you can see my word file. So take down the second aim to implement multi-threading, using P threads, THR. Take down, write down P threads just like this, okay? Because this is the C keyword, THREADS. To implement multi-threading using P threads for, sorry, for printing even numbers, odd numbers, and small alphabets. Okay, so have you jotted down? Have you jotted down to implement multi-threading using P threads for printing even number, odd numbers, and small alphabets? अभी भी नहीं किया पर क्यों नहीं रहा अटेंडेंस Just give me some minute. It's not getting downloaded either.